All right, we're going to start talking about exponential and logarithmic functions. So in these problems, we're going to need to have a really strong understanding of our exponent rules, in particular how to work with fractional exponents and negative exponents, kind of what those different things mean. All right. So for our first one, we have 27 to the negative 1/3 power. We can kind of apply the two different aspects of this exponent. Either one can kind of come first. I can either first figure out what that negative is going to do to it and then figure out how the fractional part is going to go, or I can kind of do it the other way, or I could even sort of do it all at once. So basically the negative is going to tell me that I have the reciprocal of this number. So it's going to be 1 over 27 to the 1/3 power, right? That's kind of how the negative is going to apply. And the fractional exponent tells me what sort of root I'm taking. So in this case, I'm taking the third root of 27. So whatever's in the denominator, that's the type of root that we're taking. Because this is a 1, I'm also raising it to the first power. Raising it to the first power doesn't really do anything. So kind of rewrite this again. So we have the cube root of 27 to the first power. Again, exponent of 1 doesn't really do anything, but if this was a higher power, you could see how that might apply. And I can also apply this exponent sort of inside the radical, or I could do it after taking the radical. The order there won't matter. I'll get the same thing. Well, in the end, the cube root of 27 is going to be 3, right? Because 3 to the third power, 3 cubed is 27. So in the end, we end up with 1 over 3. All right, next one, we have a decimal exponent. So decimal is not particularly useful to us. We could, we could use a calculator, and that can handle the decimal exponent fine, but I'd like to represent that as a fraction to work with it. So 3.5 is the same thing as 7 over 2 as a fraction, as a reduced fraction. So here, now I have a numerator for my exponent that's not 1. So I'm going to be raising it to the 7th power. And I'm going to be taking the second root, or the square root. So I have the square root of 4. And I'm going to raise that to the 7th power. Now again, I could raise that exponent on the inside, but then I'd be having a pretty large number that I would have to then take the square root of. So it's a little easier for me to first apply the square root, then raise it to the power. So square root of 4 is 2. 2 to the 7th is 2 times 2 times 2, 7 times, which is going to be 128. All right, and then our last one, it looks pretty intimidating, but it's not too bad. We're going to kind of break it up into parts. 27 to the 1/3, right? Remember, that's really just the cube root of 27 to the first power, but again, I don't really care about that. And 64 to the 1/3 power, also again, cube root of 64 to the first power, but again, I don't really care about that. Raised to the -2. I'm going to deal with that part last. I'm going to simplify this. So cube root of 27 is going to be 3. Cube root of 64 is actually 4. The -2. Plus 4 is 7. So 7 to the -2. And then I'll go ahead and deal with this. So a negative means 1 over. So 1 over 7 squared. And 7 squared is 49. So overall, our answer ends up becoming 1 over 49. If we go ahead and square that. Cool. All right, I'm going to go ahead and clear this and do a few more problems. All right, so on the back side, we're going to kind of go the other direction with this. We're going to start with some radicals, and we're going to try to write those in exponential form. So our first one we're going to look at is number 17. So we have the 5th root of x to the 4th and y to the -6. All right, so a 5th root, I can always replace that with an exponent. So I'm going to do that. We have x to the 4th, y to the -6. So instead of a 5th root, I can make this as a 1/5 exponent power. Okay, and then our rules of exponents say, in this case, to distribute this 1/5 in. So I put 1/5 times 4 is 4/5, and then 1/5 times -6 is going to be -6/5. Now, in general, we could leave it like this. I mean, technically everything is right here. In general, we don't often leave negative exponents in our problems. We apply the negative part to this to change it a little bit. So I'd end up with x to the 4/5 over y to the 6/5. So in general, I would want to write that out without a negative exponent in the end. But this also is fine. It's also correct. All right, I want to look at number 20 next. So number 20, we have the 4th root of a big fraction here. We have 3 to the 4th times a to the -6th. And then on the bottom, b squared. So just like I did last time, I'm going to change this from a radical to an exponent. So this is going to be to the 1/4 power, right? Because I was doing the 4th root. And then I have 3 to the 4th times a to the -6th, and then b squared. So I'm going to go ahead and distribute my exponent on the outside to everything here. And I'm allowed to do that because I'm allowed to apply this across multiplication. If this was addition here, I couldn't just go ahead and distribute that exponent in. But I can do it in this case. So 1/4 times 4 is going to give me 1. So there's 3 right here, multiplying that in. 1/4 times -6. So -6 over 4. Although that is reducible, right? We can reduce that. So that would reduce to -3 over 2, which I'll do here in a second. And then 1/4 times 2, right? That's going to be 2/4, which is a half. So rewriting this really quickly, 3a to the -3 over 2, and then b a half. Now again, we don't really like to leave our expression, our final answer, with negative exponents in it. So if we have a negative exponent on the numerator, all that's going to do is just flip down to the denominator, right? Because negative just means 1 over this, so it would go down here. If I had a negative in the denominator, it would actually flip up because in the denominator I would have 1 over that thing, which, and when you divide, you flip it, so it goes to the other side. So our final answer here, 3 on top, a to the 3 over 2 on the bottom, b to the 1 over 2. And that would be our final answer for that one. Okay, and I'm just going to do 2 more from the bottom section. So I'm going to clear this. Okay, so I'm going to do number 22. So in this problem, what we're doing is we're applying exponent rules to simplify this as much as we can. So we have the square root of 27 times the 6th root of 27. This is nice and convenient because we have the same number inside of our radical. If we don't have the same number inside of our radical, we might want to think about how we can rewrite them. And we'll see that on the next one. But this one I'm doing, I'm going to convert this into an exponent, so to the 1/2 power. And convert this into an exponent as well, to the 1/6 power. And when we multiply two things with the same base, the base of 27, we simply add the exponents together. So 1/2 plus 1/6. So a half is really 3 over 6. So we're doing 27. 3 over 6 plus 1 over 6, which is 4 over 6, which would simplify to 2/3. So we end up with 27 to the 2/3 power. And that, you might think that's done, but in this case, it's actually not, because this number is reducible, right? That denominator of 3 means I'm taking the cube root of this base And 27 has a nice cube root. So if I change this into my radical form, raise that to the second power, that's the numerator there. So the cube root of 27 is 3. 3 squared is going to be 9. So our overall answer is 9. So we got from this to just 9. Not super obvious that that was going to be the case without applying all of our rules. All right, and now for our last one. 25. We have the cube root of 32 times the square root of 8. All right, so now the first thing is I can't be applying my exponent rules right away here because, well, I don't have the same base. Like the last time I had 27 and 27, I don't have that right now. But conveniently, these two numbers are both powers of 2. So I can rewrite them that way, and that's going to be the first thing that I do. So 32 is really 2 to the 5th. And 8 is 2 to the 3rd, so square root of 2 to the 3rd. Okay, now, since I have the same base, I have a base of 2, I can use my exponents. I can rewrite these using exponents. So I have 2 to the 5 thirds, right? 5 because that was the power of 2 that I'm working with, and 3 because that's the type of root that was going on, times 2 to the 3 over 2. 3 again because that was the power of 2, and 2 because really, even though there's no number here for the index of my radical, square root is a root of 2. All right, now again, I need to add my exponents. That's what I'm supposed to do when I multiply two things with a common base. So I'm adding 5 over 3 plus 3 over 2. Not a common denominator here, so I'll change those both to 6. So that's going to be 10 over 6 plus 9 over 6, right? Yep. That's 19 over 6. So we have 2 to the 19 over 6. All right, that is not lovely. So I'm not actually going to calculate that out because I don't think that will be very good. I'm just going to go ahead and leave it exactly like it is. 2 to the 19 over 6. Or if I really, really wanted to, in simplest radical form, I could do something like this. The 6th root of 2 to the 19. This would be in radical form. This would be in our exponent form.